Hello grade 10s and welcome. This is Mr. T. I'm excited to be presenting to you another video under the topic equations. I'll be presenting to you a video on simultaneous equations with a particular focus on two methods. That is the first method, which is the substitution method, and the second method, which will be the elimination method. So we want to solve the following equations to get the value of x and y using the substitution method. So the first thing that you need to do is to label your equations. Label the equation 1 and equation 2 respectively. So I'm going to opt to work from equation number 2. And I'm going to make y the subject of the formula. I'm going to make y the subject of the formula in the equation number 2, the one in purple. If I do that correctly, I should get y is equals to 4 minus 2x, which is still the same equation number 2. Thereafter, the substitution method comes in. I'm going to substitute that y value that I've just calculated, this y value here, the 4 minus 2x, into the place of y from the first equation. So if I do that correctly, I should get 4x minus 5 open bracket 4 minus 2x is equals to negative 20. Notice that equation 1 no longer has y. In place of y, I now have 4 minus 2x. I have created a simple linear equation which I can just solve by removing the brackets. I'll get 4x minus 20 plus 10x is equals to negative 20. If I simplify that further, I'm going to get 14x is equivalent to 0. I proceed. 14x is equals to 0. Solving for x, I divide both sides by 14. I'm going to get my x value to be equal to 0. Very simple. So I now have the x value. I need to find the y value. I'm going to substitute again the calculated value for x. What I've just calculated for x, substitute the x value into the second equation. So if I do it, I'm going to get y is equals to 4 minus 2 times 0. Therefore, my y value is equals to 4. So I've solved my equations simultaneously using the substitution method. I want to proceed to the second method, which is the method of elimination. It's suggestive. Eliminate, we've got to remove something. But what equations are we working with? We're working with x plus 2y is equals to 4 and 2x minus y is equals to 3 as my second equation. So again, here it's out of choice. I'm going to say equation 1 multiplied by equation 2 to eliminate x. Equation 1 multiplied by 2 to eliminate x. What is the whole objective of multiplying by 2? Is because I want the coefficients of x to be the same, irrespective of their sign. Whether positive or negative, it doesn't matter. So if I do that, if I multiply by 2, I get 2x plus 4y is equals to 8. Still, that is my first equation. My second equation remains the same. It doesn't change. Thereafter, I'm going to say 2 minus 1 to eliminate my x. That's very important. I'm going to say the second equation minus the first. Or if you want, I could reverse that immediately. I could say equation 1 minus 2. Doesn't matter. So I could say equation 1 minus the second equation. And if I simplify that correctly, the 2x and the 2x cancels. I remain with 4x minus y is equals to 8 minus 3. I've already eliminated x. I now have y's. It's a linear equation. If I simplify that, 4y minus y, that gives me 5y is equals to 5. Dividing both sides by 5, I get my y value to be equal to 1. To eliminate y, I can say the second equation to eliminate y, I can say equation number 2 multiplied by 2 in order to eliminate y. Equation 2 multiplied by 2 to eliminate y. So I'm going to have x plus 2y is equals to 4 as my first equation. It doesn't change, but the second equation becomes 4x minus 2y is equals to 6. I've multiplied it by 2. I'm going to add this time around because the coefficients of y are different. One is positive, the other is negative. To eliminate, I have to add. So I'm going to add equation 1 to equation 2 to eliminate y. So add equation 1 and 2 to eliminate y. Thereafter, you're going to get x plus 4x is equals to 4 plus 6. Simplifying that, you get 5x is equals to 10. Dividing both sides by 5, you get x equivalent to 2. So that's my x value. I hope you enjoyed that. Bye-bye.